Greetings to you, ladies and gentlemen. Welcome back to Shexa's YouTube channel. Please like, comment, share, and don't forget to subscribe. Let me say this. These lectures, they are meant to take somebody from another area of study that is not related to IT, so that they get a full understanding of what we are talking about when it comes to databases and warehouses. So if you're an expert in this area of databases and warehouses, it might be boring for you because I will take all the time to explain some of the things that are assumed to be simple by those that exist within the area of IT, or the field of ICT and electronics, or computer science, or information systems. So bear with me. I will go as slow as I can so that you all get all the concepts. I take a simple concept or a complicated or complex concept and simplify it. So that's what we're going to talk about. To talk about database management and warehousing. And today we're going to talk about SQL data types. SQL data types. So it's not types here, but it's data types. It's data types. So right, so it's data types. We'll talk about SQL data types, and then after data types we'll talk about constraints, SQL constraints. So I will talk about these the data types and the most popular ones. Those are the ones that I'm going to focus on. I will talk about the most common ones, and then the constraints as well. I will talk about the most common ones, and those ones that we'll talk about mainly are the ones that will be examined. So that's it. Let's begin our lecture, and we'll start by asking a question like what is it that we call an SQL data type? SQL data types define the type of value that can be stored in a table column. So that's one of the definitions that I have here. It raises it's a definition of the type of value that can be stored in a tables column. So for example, if you want a column to store only integer values, these are these are considered as whole numbers most commonly. And so I'm saying, for example, we want to have a column that stores integer values, then we can define its data type as int. So like we used to do when we talk about the age, somebody's age, it is defined as int. That's the data type. So in other words, what are we saying? Let me define this data type in other words. Let's say you are asked to give somebody your age. That value that you give, I'm 28, I'm 29, I'm 35, I'm 50, I'm 60. So is that 60 an integer? What is the type of value 60? The type of value 60 is an integer. So if I ask, for example, what is the price of this apple? The price of this apple is $30.50. So $30.50, it's having a comma. So I might call this as double, or I might call this as float. So float, that's the data type, that's the type of data, that's the type of value, to be stored for a certain column. That's what we are calling data type. Another example could be, can you give me the address of can you give me your home address? what are you going to provide as home address? What type of, you say 33 10 World, Harare, Zimbabwe, whatever that you are going to give us. All that you have an integer as house number, you have some words, you have some characters. So all this combination, it's now called an alphanumeric value. So what can you say about this value? It's a text. So you can call the type of this data as text, or you can say it's varying characters, to say we have integers and full stops and maybe commas. So it's a data type with varying characters. That's why mostly we call that as varchar. Varchar standing for various characters or varying characters. So this varchar, it consists of, or it allows you to put comma, dollar signs, A, B, C up to Z, 1, 2, 3, 4, 5, and all other characters that are allowed by the system that you will be using at that moment. So the data type, if I ask you about the address, you give me text. If I ask you about your name, you give me text as well, but it's now small. So text allows us to give a lot of, or long text, in other words, or text with more lines, or with more words, or with more characters. But when it comes to variable character, it consists of small, or it takes less space. So if you want to put text to a column which is defined with the variable character, it will tell you that the space is not enough for the value that you want to put. So you better define this column as text. So you will see when we start to write the queries about these things. So SQL data type is an attribute that specifies the type of data of any object. The type of data of any object. So each column, variable, and expression is a related data type in SQL. You can use these data types while creating your tables. You can choose a data type for a table column based on your requirements. So that's what a data type is. And somebody can ask, what does an SQL data type tell us? What exactly do we get from SQL data type? Like said in the definition, it tells us the type of value, right? And as I said in my explanation, I said it tells us, when I differentiated varchar from text, varchar takes less space than text. So data type also tells us the amount of space to be used by the column, or by the variable, or by any object that we are defining. So a data type tells us the range of exact values in storage space to be occupied by the column's value, that is in relation to databases and warehouses. So from this, I'm sure that we now know what an SQL data type is. We now know what an SQL data type can tell us, us as programmers, or as script writers. Let's now talk about the categories of data types. Categories. We have numeric data types. When we talk about numeric data types, like I said earlier, I talked about the price of an apple and the age of somebody. And when I said the age, we define that as integer. And when we talk about the price, it's now a double or a float. So we have a number of data types that are related to numeric values. For example, we have that is we have integers, and then we have float, we have double, we have bit, a bit which is either a 0 or a 1. So a 0 or a 1, it takes up a certain amount of space. So let's talk about big int as the first one, which is numeric data types. So a big int, that's the data type, and then a big int value ranges from -2 to the power 63 up to +2 to the power 63 minus 1. So those are the values that are allowed as big int. So if you take a value that is before -2 to the power 63, then it's not allowed in this range. And if you take a value that is after 2 to the power 63 minus 1, it means it will not be allowed. It will throw an error. So you will need to give an exception if you are writing a code, or the MySQL or the database that you will be using will throw an error, and it will be passed to your program if you are writing a program that is linked to a database. And this big int, it takes 8 bytes of space. It takes 8 bytes of space. And we now know to say, if I am talking about big int, it's a big integer. So it's an integer that is big. And how big is that integer? It's big in such a way that it exists within this range, -2 to the power 63 to +2 to the power 63 minus 1. So that's the big int. And then let's rush to an integer, the most common one, integers. So it ranges from -2 to the power 31 up to +2 to the power 31 minus 1. And this takes up 4 bytes. You can see that the amount of space is now reduced by half, and the range is also reduced. The range is also reduced. So this integer is smaller than big int. So the values that exist within integer data types, the values that exist within integer exist within a smaller range, while those that exist within big int, they are in a bigger range. And you can see that if you declare a data type, if you declare a column with a data type big int, it's going to take more space. It's going to take more space than you might require for a certain value. Right. So what I'm saying is, a big int, if you say maybe you want to use a certain value, maybe 300, and you declare the data type as big int, and the values that are going to put in there, they don't exceed 1000, then why are you declaring a column as big int, of which big int takes 8 bytes? So if you're going to have 32, maybe 32 values, it means 32 by 8 bytes, which is more space taken. So that more space is wasted because it's not used. So you are declaring to say, I need 8 bytes, of which you need 4 bytes, or maybe you need just bits, and in that case you don't need to declare it as big int or as integer, because it takes less space. So you need to save space. So this also allows the database administrator to save space and allow more data to be stored within the database. And then let's talk about another type, which is small int. Right. So small int, it ranges from, you can see from this, the size is being reduced, and the range is also being reduced. So the small integer ranges from -2 to the power 15 up to 2 to the power 15 minus 1, and it takes up to 2 bytes of space. 2 bytes of space. So numeric data types, these are the exact number data types that use integer data. So to save space in the database, use the smallest data type that can reliably contain all possible values that exist within the domain of your system. For example, tiny int, maybe I will talk about the tiny int, which is the next one. Tiny int, it ranges from 0 up to 255 and takes 1 byte. It's 1 byte of space. So for example, I've talked about saving space. So if you want to save space in your database, use the smallest data type that can reliably contain all possible values that you need in your system. For example, I said a tiny int would be sufficient for a person's age, because no one lives more than 255 years, except maybe Abraham, those of the old ages. But now, do we have anybody older than 255 years? So this is the most or this is the correct data type for age. If you just use int, it will work, but you have wasted a lot of space. You just need 1 byte, but you are declaring 4 bytes. So 3 bytes are wasted. Right, so that's it on numeric. Let's talk about other numeric data types. We have float, and I've added size and d inside the brackets. Of course, with tiny int and other integers, you can put the size inside, but with float, I want to emphasize this because it's having different number of parameters, which is 2. It's by parameters I mean size and d. These are the 2 parameters that are defining the value that is going to be inputted onto this column with data type float. So a float is a value that contains a comma. A float defines a value that contains a comma. So the total number of digits is specified by size parameter, and the number of digits after the decimal comma is specified by the d parameter. So size determines the number of the number of digits, and then d determines the number of digits after the decimal comma. So float is there for us. And then we have double. Double is defined the same way as we define float. Double, total number of digits, is defined by size, and d, number of digits after the comma. But float is smaller than double, or I mean float takes less space than double. So that's it on numeric data types. Let's talk about date and time data types. Here we have the date data type. This stores date like maybe June 30, 1991, or any kind of date, any date. It takes any date, but this date is an SQL date. This is an SQL date. So it might be 30 July 1993, 30 April 1997, whatever, 2003, or whatever the date. So date takes just date. Date data type takes only date. And then time stores a time, any time of the day. For example, 12:30 p.m., 11:55 a.m. or whatever the time. It takes only time. And then we have date time data type. So date time, it ranges from January 1, 1753 up to December 31, 1999 or 9999. So that's date time. It's having this range. So it doesn't allow any date before January 1, 1753 or date after 31 December 9999. So that's the date time data type. It's so definite that date time range is going to change by time. For example, when we get to a certain date like December 30, 9997, it means by that date the range of data time will have changed. And then we have small date time. This ranges from January 1, 1900 up to June 6, 2079. So that's more data time, right? So another thing that I want to talk about here, when we say data time, it also takes the time with it. It also takes the time with it on other versions of MySQL databases. Right. Let's now talk about characters and string data types. Character and string data types. Right. We have under this category we have character, which is char, which stores a date. No, I've made a mistake here. I didn't change the text after this, so let me change. So a character data type stores any alphanumeric value. So the size the size of a character column is byte based, not character based. For example, if you define a column as character with size 10, the column has a fixed length of 10 bytes. So each character, the character that you have will be of size 10 bytes, not 10 characters, not 10 characters, not. So the example that I gave you is when I say character 10, like this. When I say character 10, it doesn't mean I'm going to have 10 characters, but it means the column has a fixed length of 10 bytes. So the size of the column, so each value that we're going to put in a column for a certain record is of size 10 bytes, not to say 10 characters. Understand me there? It's 10 bytes. So the 10 value that is there, it defines the size of the character. So some of the characters, they take a lot of space, some takes smaller space. So character size is defined by the programmer or by the script writer. So if you want to store multiple byte characters in a character column, keep in mind that the total number of characters you can store in the column might be less than the total number of bytes you can store in the column. So by this I mean some programmers may say may write a script somewhere else with maybe using another language and have more than one column, more than one character combined together and formed or come as one character. And if you want, in that binded character will take more space, and you will define the size of the character inside these two curved brackets. So make sure to define the byte size of the character column so that it can hold enough characters for your purposes. And then we talk about the variable characters. I think I've talked about this one. Varchar standing for varying characters or various characters. So this one takes up 1 byte per character. It takes up one byte per character, plus 2 bytes that hold length information. So if you put only one character, it's 1 byte plus 2 bytes that stores information about this column. And then for instance, we have, if you set a variable character with 100 data type, it means 100 characters, and these 100 characters, each character is taking 1 byte. It means 100 bytes plus 2 bytes that is storing information, length information. So for example, if we declare this variable character 100 data type and put gen as that is JEN as the data, as the actual value, it means what is the size of this what is the size of value inserted at this column. The size will be 5 bytes. Why? Because we have 3 characters, each character taking 1 byte. So 3 bytes plus the 2 bytes that are used for length information. So that's varying characters, variable character. I think the way we use variable character, we are all familiar with it. But if you're not familiar with the way we write variable character or declare variable character column, then you will see, don't worry, you will see how we do it as we will write some SQL queries in this lecture. So another type is text, as I said, variable length storage with maximum size of 2 GB data. So a text can be a lot of text, a number of bytes, a number of pages maybe. But you can also define the length to say, I don't want this to be to be larger than this. So the risk that you need to be very careful with is when you define a certain column with data type text, you need to be very careful with the length, because somebody can write a code, can insert a code that is going to be executed, of which it will be executed the moment you insert the value into that column with a text data type. So for security issues, make sure you define the length of the text data type, and make sure the maximum length is relevant for the domain, or is relevant for the values that are for all possible values that are going to be inserted to that column. So we have varchar max. It's not supported in MySQL, but the max is used to state the maximum number of characters that are taken or allowed for that column. I think these are the most common ones when it comes to data types. There are more. You can Google and look at them and do some experiments in Workbench or Navigate or any platform that you might be using wherever you are. Now let's talk about SQL constraints. SQL constraints. What is it that we call a constraint? SQL constraints are rules used to limit the type of data. Get this correct. It's the type that is limited. Type of data that can be inserted into this column, into this table, or table column. So to maintain the accuracy and integrity of the data, you need to define SQL constraints. So it also limits the values that are allowed within a column. So SQL constraints, they are used to specify rules for the data in a table. They are used to limit the type of data that can go into a table. This ensures the accuracy and reliability of the data in the table. So if there exists any violation between the constraint and the data action, then it means the action is aborted. The action itself is aborted. So the action is going to be aborted. The action is going to be aborted. So let's now talk about the types of SQL constraints. The types of SQL constraints is described or is defined. These SQL constraints, they govern the data type that is going to be entered for table columns, or any data that is going to be inserted into the table is governed by SQL constraints. Right. So the types of SQL constraints that we have column level constraints and table level constraints. So these are the two types of constraints that we have. Column level constraints, these are the rules that cover individual columns. They cover individual columns. Let's say column first name and column age. These two columns are different in terms of the rules that govern them. For instance, the age column must not have values that are less than 0. And then age, the F name, we have variable characters is the actual data. So these two, they have rules that govern them, but each column is having different rules governing each the data value that is going to be inserted or allowed into it. So column level, it governs individual columns. For example, when we write SQL queries or SQL commands, we define constraints such as check age greater than 0. So all the values that are, for example, we have this SQL query. I will read it from scratch, from where it starts and up to the semicolon. It reads create table, and this my table is the name of the table, and then name, and we have character of size 10. You know the meaning of this. And then not null is one other, is a constraint, but in other terms they might they used to call it an attribute, which is defining the values that are allowed into this column name. And then we have ID, which is an integer, and reference is ID table ID, and age column now is of type integer, and the rule that is governing age is that the age must be greater than 0. Any age that is below 0 or equal to 0 is not allowed. So that's the rule that is governing age only. So ID is not governed by this rule. That's why we are saying it's covering only this individual column. Then we have table level constraints. So these table level constraints, they cover multiple columns of a table. They cover multiple columns of a table. So for instance, table level constraints, let's have this example. We have create table, your table, you give the name of the table, and then you specify the column first name, you specify the data type and the length, and then you state that the values for this column must not be null. And then another column, last name, character size 20 bytes, and not null. Now you are specifying or enforcing unique constraint for these two what can I call them, tables, attributes, or fields. Table, columns, attributes, or fields. So these two, first name and last name, they are all unique for this table called your table. So that's column or that's table level constraints. So let's just open our workbench and write. I hope you all have the last lectures database in tables, and I hope you didn't manipulate them in such a way that this lecture is going to be affected. So if you haven't created the database, please make sure you copy the SQL queries that are in a certain file, and the link to the file is provided in the description, or you can just watch the previous lecture where we talked about how to create the database, how to create the tables and other things, so that you copy up with what we are going to do today. Let me open the workbench. Those using Navigate, you can also write the same queries. Right, so this is the connection that I am using for this lecture. Right, today I've maximized the size of my font. Right, so these are the queries that we wrote last time up to this point. So these are the queries that we wrote to create the database and its tables. So what we want to do today is we want to write a query to create a table. We want to write a query to create a table. So we'll create a new query tab. So we want to create so the first thing is to use, we need to select the database that we're going to use. Use the database track management db, and then it's just use. Right, so this is the database that we are going to use, and we want to create another table. Maybe it's a table called users. So let me just run it and maybe move this one so that you see the table, the database that we are using. So I run this, it's executed successfully. Right, and then we create our table. The table is going to be called users. Maybe these are the users that are going to log into our system. And then the columns, the first column I'm going to call it first name, and then it's a variable character. You all know this. So this variable character, that's what we said is varying characters, and it's of size 4 bytes. And then the number of characters, the number of characters allowed, let me just say first name, let me just say 32, and then put a comma, and then say let me just say not now. So we are specifying to say this, or let me just leave it without not now, so that you will add not now when we talk about alt command. Then last name, L name, which is variable character and size 32, then we say username, which is also a variable character of size 32 as well, and then put a comma, and then email address. What I want to illustrate here is table level constraints. So this one is also a variable character, so don't worry about other things that we're going to put in there. Email, let me just say CS4. Right, now I want to add unique constraint, so I will just say unique. So which table columns are unique? First name, then L name, then we have what? Username, then we have email address, then we close this bracket. Right, so this is the query. So for safety, maybe the table already exists. Do we have table called users? We don't have it there. Create table if not exists. Right, so we run this query. So what we are saying is the query is executed successfully. So this uniqueness is applied to all the tables columns or to multiple table columns. So that's table level constraints. You specify the constraint and then state or list the table columns that are supposed to have this constraint. So that's it. If we maybe, let me just check if we now have users. Yes, it's there. Let me click it. You see that we have all those columns. We now have our columns. Right, so that's it for table level constraints. That's it for table level constraints. Let's talk about some examples of SQL constraints that we have. Right, so not now is one of the constraints or one of the attributes that defines what data is going to be allowed for a certain table column. So by default, a column can hold null values. By null values, we mean nothing is added as a value to a certain column. So when you say nothing is added to a certain column, let's say the database is having first name, middle name, and last name, and middle name, and a certain user does not have middle name, it means the value that is allowed there, we need to allow null values for that column, because not everybody is having a middle name. We may have first name and last name, and some might have first name, middle name, and last name. So not now is a constraint that is used to disallow or to reject null or nothing for specific or certain database columns. So not null is there to avoid columns from or to restrict columns from having a null values. So null value is not a zero. If you put a zero, it's a zero is a value. So no value that's null. Null is no value. If you put blank space, that's a value. Null is nothing. You didn't specify any value for a column. So by default, a column can hold null values. But if you don't want to, if you don't want a column to have null value, use not null constraint to restrict a column from having a null value. So not null is used to prevent inserting null values into the specified column, considering it as a not accepted value for that column. Right, so this means that you should provide a valid SQL not null value to that column in the insert or update statements, as the column will always contain data. So the column with not null constraint will always have a value. So when you write an insert command, maybe from Java, or from PHP, or from any other language, and you want to pass it to SQL or to your MySQL database, then it means the value, you must have a value for that column with not null constraint. Right, so that's it. Here's an example from our previous lecture. Here we have source and destination. Source and destination cannot be null for a certain trip. We have a trip which does not have the source and the destination. So if you don't have source and destination, then do we have a trip? We don't have a trip. But maybe we can register to say we are going to have a trip next week, right? Or we are just going to have a trip from this source to this destination, but we don't have the date for this trip to say is the departure date is this and the return date is this, but we may record and then later on update to say this trip was then started on this date and ended on this date, and the amount of fuel and other things. But for this table we specified that source and destination must not be null, but other columns may have null values. So let me open the previous trips table. Trips table, where's trips table? Here it is. You can see here we have not null and not null. Maybe you are not seeing. Let me just zoom it. Right, so I hope today you are seeing everything that I'm projecting to you here. So that's it. We have our not null. This one is also not null. So no values are allowed for these two columns. No values are allowed for these two columns. Right, so that's it for not null. Let's now talk about unique constraint. I think unique, we've talked about it. Unique constraint ensures that all values in a column are different. It ensures that a column will only have unique values. So for one row, for row number 1 up to whatever the row we have in a table, the column will not have repeated values. A unique constraint field cannot have any two records having identical values in a column. So therefore it prevents two records from having identical values in a column. So that's it. It's as simple as that. Both the unique and primary key constraints provide a guarantee for uniqueness for a column or set of columns. For example, here we have a column called drivers. Table called drivers. We stated that phone number, no two drivers can share the same phone number. So the phone number column will have different values and no two or more values will be identical. Therefore, it's unique. Let's now talk about the primary key, which is the one that enforces entity integrity. As discussed earlier in other lectures, right? So primary key constraint specifies that the constrained columns values must uniquely identify each row. So unique and primary key they all identify a row or a record in a table. So a primary key uniquely identifies each row in a table. Primary keys must contain unique values. They must contain unique values. For example, each driver must have a unique phone number. Each driver must have a unique EC number. Each driver must have a unique driver's license number. So that's it. Different values for the column. So a table can have only one primary key, but may have more than one unique column, columns. And in the table, this primary key can consist of single or multiple columns. So we have compound keys and single column key. So a primary key can have more than one column. So unlike other constraints which have very specific uses, the primary key constraint must be used for every table because it provides an intrinsic structure to the table's data. Here we have our table called drivers, and we have our primary key called ID number, and the ID number per driver is different and the phone number per driver is different, but we may have more than one columns with the unique constraint, but we only have one primary key per table, which is going to be used to identify or to uniquely identify each record. Another example is here. So the way we specify primary key, I think I've illustrated two ways. The first way is illustrated to our left, that is on drivers table, and the other way illustrated on the right side or in trucks table. Here we have our primary key called reg number. All this can be found from the previous lecture or previous video tutorial. Right, so that's it on primary key. Another constraint is a foreign key constraint, which enforces what? Referential integrity. This prevents actions that would destroy links between tables, like illustrated in the previous lecture where we talked about the links between truck and drivers. We have truck driver table, and the truck driver table also links the trips and the truck and the driver. So that's it. I think you remember that. So the foreign key constraint identifies the relationships between the database tables by referencing a column or set of columns in the child table that contains the foreign key to the primary key column or set of columns in the parent table. So I will on this I will show you what we call the child table, what we call the parent table, and how the foreign key is linked, is used to link the child and the parent. So here we have the parent table. This is all about the previous database and tables that we have created earlier in the previous lecture. If you haven't watched that, please watch it, or just get the file with SQL queries and then paste them on your text editor, run them, get the database, and then follow what we are doing here. Here is the primary table or the parent table. I commonly call them primary tables because these are the parent tables that are linked to. Then we have our primary key, which is what? ID number, right? So with our ID number as the primary key, we have a child table. and the child table in this case is truck driver, which is what? Linking the driver and the truck. So here is what happens. This primary key in drivers is a foreign key in child table. And for your own information, you can see that in child table called truck driver, we have driver ID number. So it's named as driver ID number, but in parent table called drivers, we have it as ID number. So you now specify to say my foreign key is driver ID number, which is existing in this child table. But this driver ID number is referencing an ID number column, which is existing within drivers table, of which drivers table is the parent table. So that's the link. That's how foreign key constraint is linking two tables. So if you now want to delete a certain driver, if you want to delete a certain driver in drivers table, you will need to delete any data that is related to that driver from the child table before you delete it on the parent, from the parent table. So to do that automatically, what you need to do is to write on delete cascade. I think I've said this in the previous lecture. So you can see that this child table truck driver is having two foreign keys, and these two foreign keys are used to link two tables. Therefore, we have our relational database. Relational database. Right. So let's now go to this other constraint, check. This allows you to specify a condition on each row. For instance, here we have fuel double check, but this constraint, I think, yes, I'm sure from what we did previously, it's not there, and we shall have it when we start to look at alt modify commands. So here is our check. It's checking that fuel must be at least one or more. And then age is illustrated earlier in the previous query. Age must be greater than 0. So that's it on this. Let's now talk about default constraint. The default constraint, it specifies a value that is going to be inserted if there are no values specified or provided for that column. So if you do not assign a default value to the column, the user leaves the column blank. For instance, if you leave a column without a specific value, then you will need to have a default value. But if you do not have a default value, say the null value is going to be inserted. So to avoid a null value, we then specify a default value. So we said by default earlier, we said by default a column takes null values. But if you don't want that column to take null values, you specify to say not null. Now, if you say not null and don't provide a value, then it's going to give you an error. But to avoid the error, you specify a default value that is allowed for that column. For instance, we say the source. We know that maybe the trucks exist in a company based in Chinoy, and the trucks will start a trip from Chinoy. So default source is Chinoy. We may not put or we may not specify the value. So if you set the option to allow null values, now will be inserted into the column. And if you do not set the option to allow null values, the column will remain blank, but the user will not be able to save the row until they supply a value for that column. So you need to specify or enforce this constraint. So that's the default constraints supplied there. And we have not null because source cannot be null. And if we don't provide a value, Chinoi is going to be provided as the default value. So this is how you can enforce or how you can apply this constraint when creating the table. And if you are altering the table, you will see in the next queries that we are going to write. Right, let's now talk about some queries or some commands. Alter and modify. The alter table query is used to add, modify, or delete columns in an existing table. So alt, it's more like altering. We are changing. It's more like change, but it's the keyword that is allowed or that is defined to be used to change the columns and to change the table structure or table object structure. And then modify is used to change column constraints or column data type. So the alter table statement is also used to add and drop various constraints on an existing table. Sometimes we need to change the data type of a column, and to do this we use the alter table modify to change the columns and the data type. So here is the syntax for altering for alter and modify. So what you do, alter table, then you specify the table name without quotes, and then you specify to say modify, and you pick or you state or specify the column, the name of the column that is going to be changed or modified, and then you state the new data type and maybe the length of the values that are allowed in there. Let's now go practical on this command alter and modify. Alter and modify. Right. So let's open our workbench. Right. Somebody was saying, why are you not adding? Why are you not putting not null on these? I was waiting for this lecture so that you see how we can change. Let's say you have forgotten to specify that these values must not be null, or these values must be unique. So this is what you can just do. This is what you can just do. So we'll start with alter, and what we want to alter is the table called trips. We want to alter the table called trips. So this is our table. Let me zoom this. Right, so this is our table. This is the previous table that we've created, the trips table, and we want to alter this table in such a way that fuel, where's fuel here, we want to make sure that fuel is above 0. We cannot say we have a fuel that is negative. I don't know how that can happen. So we want to have the check constraint on this column. So we open this one, and maybe we can comment this, and then we use this database. And then what we do next is we use the alter. We say alter, and what do we want to alter? We want to alter a table. And which table do we want to alter? Let me zoom this one so that we see exactly what I'm typing here. Right, I say alter table, and the table that I'm going to alter is called trips. Yeah, and I go to next line for just smartness, then say add. What do I need to add? It's a constraint, and what's the name of the constraint? It's check constraint, and then I specify the check here to say fuel column must have values that are greater than 0. Most people are confused with this statement. Most people are confused with this statement because they think to say, are we saying if the value is greater than 0, then it's an error? No, we are saying values that are greater than 0 are the values that are allowed for this column called fewer. So we run this. It's running here. Right, outer table is it has been executed successfully with 0 duplicates, 0 warnings, and 0 rows affected because we don't have any records added now. Right, so that's it. We have our alter. So that's how we write the alter to change or to enforce a certain constraint. Let's now comment this and write another constraint, or we may not comment it. It depends with your choice. Right, let's alter. You know, from our previous lecture we talked about trips, and we said we need to say source's default value must be Chinoi, but now we didn't specify it here. We will now want to specify it. So what we do is we still use alter, and we alter what? Alter table. We want to alter a table, and the name of the table is called trips. And what do you want to do? We want to add a constraint. No. We want to set a default. So what do we do next? We alter a certain table. So we say alter what? A certain table column called source. And what do we want to alter? We want to set a default value. We want to set a default value, and the default value that we're going to set is what? Let's say we want to set Chinoi as discussed earlier. So Chinoi is our default value for this column. So let's execute this and check. Let me zoom it in so that you can see the whole statement. Right, so we said alter table called trips, and then we are now altering the column itself. What is it that we are doing with the column? We are setting a default value. So the default value that we have set is Chinoi. So Chinoi is the default value that is going to be inserted if we don't provide any value. Right, so that's it with alter. I'm sure now that we now know how to use the alter, but I'll provide more examples so that you more practice. You become perfect when you do more practice. So I will provide more examples for you to practice with. Let's say we need to add more constraints. We need to add more constraints at once for some columns, for several columns. What we may do is we may say alter table, and then the table that we're altering is trips, and this table trips, what do we want to do? We want to add constraint. So we say add constraint, and we give a name to the constraint. So here the constraints that I want to add are these two constraints, this one and this one. So I'm assuming that the table does not have those two constraints. It doesn't have any harm to rerun or to execute a constraint that is already enforced. So what we can do is here we name the constraint. And what is the name of the constraint? We say fuel, and let's just say fuel and what? And destination. and destination. Previously we have enforced the default value constraint for the source, and this time we need to have destination here. That's the name of the constraint, and then we specify the constraint. We say check, and then in there we specify to say fuel must be greater than 0, and what, let me move this to the side, maybe to that point, and destination must be equal to Mozambique, Moza, let me just say Moza. Here I said equal comma instead of saying end. That's why I'm having an error there. Right, so Moza, that's the destination. I may specify in full. Let me just say Malawi, which is not long. So I've added this constraint. That's the constraint for these two columns, fuel and destination. So I can execute this. Let's check if it's going to run successfully. It's running, it's running, it's running. Perfect. It has been executed without any errors. So that's it on altering and adding constraints. So alter, here we've talked about alter and the constraints, but you can also add columns. But before we add columns, let's just delete this constraint. Let's just comment it out, and let's say you no longer want the columns to have those constraints. What you can do is you can alter the table and drop the constraints. For instance, you can say alter what? Table. And what's the name of the table? It's trips. We'll talk about trips today. And what do we want to do? We want to drop a certain constraint. And what is it that we want to drop? It's the check constraint. And what's the name of the constraint? You remember this is the name of the constraint. So you just copy it and paste it there. You terminate. You run. So we are deleting the constraint that we have. We are dropping or destroying the constraint. You run it. Now we no longer have this constraint standing. But if you want it, you can just execute it as illustrated on this command. Right. So we are done. I think we all now know the alter and the drop commands. Let's now talk about modify. And when modify is used to manipulate domain integrity constraints. E.g., you can change the data type, you can add unique or not null constraints. But before we do that, let's just add a column to our previous tables. Let me check. I think we've talked about the tracks, and we didn't add the color here. The color. We don't have color for our vehicles. So let's just add the color for this table. So we just write alter table. We are now adding a column. Alter table called what? Drivers. No. It's trucks. And what do we want to do? We want to add. What do we want to add? We want to add a column. And the column that we're going to add is what? Trucks color. And color is of what type? It's a variable character, and we'll state that it's having what? Just say 64 characters. That's it. I'm done adding the column. So if you want to check, you can check here to say this is tracks is here, and these are the columns. We don't have color there, and if I execute it there like that, you will see that if I refresh here, we now have color column. So we have added it using the alter. You can add many columns. You just write, you put a comma here, and then add another column, then you state the type, maybe it's size 10 bytes, you specify another column, and so forth and so forth. But we just want to add only one, that's why we are ending here. Right, so we comment this. I want to save it. We comment this one here, but let's save it. Let's call it part 2. Right, let's now modify. Like I said, modify is used to deal with the domain integrity constraints. For example, changing the data type, adding unique and not null constraints. So let's do this. Let's alter table drivers and modify. Let me just check our drivers email, drivers table. Where is drivers table? Where is it? I can't see it. Right, here is our drivers table. We have our email here. We want our email to be unique. We want our email to be unique, and we want to add another column. So I will show you how you modify this at the same time adding another column. So that's what we're going to do here. We say alter table, and then alter table. The table that we're going to alter is drivers. And what are we going to do? We want to modify, so you can say modify. And what we want to modify? The column called email address. And what is it that we want to do with this? We want to change it to text data type, and we specify the size or the length. Then we specify that it's now unique. So what we have done here is we have changed the data type. Previously it was variable character, but now it's now text with that size. Previously it wasn't unique, now is unique. You see that? Then we go next. We now want to add. We add what? A column called what? Home address. And this is of text, and we specify the length like that. We are done. So here we're adding a column. So if we want, we can open drivers here and see the columns that we have. These are the columns that we have, right? And if I click drivers here, you will see that here these are the columns and the data types that I have. Email address is variable character of that size, but if I execute this, I'm having an error somewhere on my query. Let me just check the error. Near D home address. I don't know the error. What's the error here? Let me try to run it again. Something is happening. Alright, I think it's because we're having unique on a data type called email address with the data type text. So it's very difficult for blob or text column columns to have unique what do we call them, unique constraints, because these are long. It contains long data, so it will take time for your system to check all those characters that exist within the text. So it's the version, all the versions, they don't allow text columns, the text data type to be unique or to be primary keys. So let's try it and run this. I hope it's going to run without an error. We're having an error again. Column email address used in key specification without a length. Email address, is it used in key anywhere as key? Right, so what we want to do here is, instead of changing the data type, let's just change the let's just add unique constraints. Here we say unique, and then we don't change the data type. Well, let me just put it into here so that we change the data type. Changing to text, it's a bit complicated because it will require us to change or to specify the number of characters that will be unique for every email address. So we don't want to cover that in this tutorial. So we're going to change the data type int to int from variable character, and it's going to be unique. And then we run it, execute it, and what's the error now? Check the manual that corruption unique at line 1. Okay, let me put variable card there. Just change. Let's just add unique constraint and try to run it. Error, duplicate column name, home address. It has been added already. Let's refresh. Right, home address is there. Email address is changed to 255. Previously it was 128. So we can still write this and change. Maybe we can modify both. We can modify here. We modify this one, home address, we leave it at that. And then here, instead of saying 125, we can say 128. And then run it and check if we're going to get an error. Right, we just have a warning, duplicate index email address too. So that's it. That's how one can modify and add a column. So we have added a column. Here we are now modifying both columns. So that's how it goes. That's how it goes. Right. It's now 128 here. It's now 128. So that's it. I think that's it for today, if I haven't left anything out. So that's it for today. Thank you very much for being with me here, ladies and gentlemen. May God bless you in everything that you are doing, and I wish you good luck in all things that you do in your life. May God protect you from all evil. In Jesus' name I pray. And I encourage you to like, comment, share, and subscribe. All these things, they motivate me. Thank you very much. Be blessed by God. Enjoy the rest of your day. Bye bye.